This giant complex of buildings overlooking San Francisco Bay is the Lawrence Laboratory at Berkeley. Some of the world's most advanced research in theoretical and practical physics is being done here. For some years now, a small group of scientists attached to the laboratories have been investigating this, a curious metal called nitinol. It has certain anomalous properties not yet fully understood or explained. It's caused considerable interest, it has generated some controversy, and it now seems that in a world searching for new sources of energy, it may have profound consequences. Research began here in a small laboratory workshop 7 years ago, when it was discovered that nitinol had apparently unique properties. The head of the laboratories was Nobel Prize-winning physicist Professor Edwin Macmillan. Can you explain what it is we're going to see?
Well, this is a piece of nitinol which was made in the shape of a coil spring, and the property of nitinol is that it when it's hot and wants to get back to the shape it was when it was made. When it's cold, it's quite relaxed and will take any shape. This is now cold, and you see I can take it and stretch it out.
So it was made in the shape.
It was made in the shape that I showed you first. And now it's cold, I can stretch it. Here I have a glass of hot water, and if I just pour the hot water on this thing, there we are. Good as new. In the cool state, it's relaxed and floppy. In the heated state, it remembers its former state. That's why you say it has a memory. So if you make the thing, if you make this piece of wire so it's straight when you made it, then when it's hot, it wants to straighten out. When it's cold, it's just as floppy as a wet noodle. You know, if you take one of these things and put hot, cold water in your hand, it's like a wet noodle when it's cold. When it's hot, it straightens out very suddenly. It's quite strong stuff.
In fact, nitinol, a nickel-titanium alloy, can spring back with a force of 55 tons a square inch. The actual phenomenon itself is not yet fully understood. An engineer at the laboratories, Ridgway Banks, set out to build an engine to harness this. In a small workshop across from his office, he designed and built a wheel with nitinol loops hanging from the spokes. He calculated that if he filled a container with cold water and another with hot water, the loops of nitinol, moving from one bath to the other, would bend, then spring back, and that the sudden spring of the nitinol in the hot water would drive the wheel around, thus becoming the world's first solid-state heat engine. He was right. This simple crankshaft wheel first began spinning one morning in November 1973 at the Lawrence Laboratories, Berkeley, marking the first time that heat had been converted directly into mechanical energy. Ridgway Banks rigged up a solar heater on the laboratory roof to keep the water warm enough to drive the engine and let it run to see if there would be any sign of fatigue in the nitinol wires. After 23 million revolutions, he found that the wheel was running stronger. No one is quite sure why this is happening. Professor Macmillan reported the nitinol phenomenon in 1974 at a special meeting of Nobel Prize-winning scientists in Germany. We'll talk with Professor Macmillan about this in our next science report.
This gets better and better. It doesn't wear out.
And we'll talk with the inventor of the first nitinol engine, Ridgway Banks.
And a metallurgist who has a long background in this attended a talk that I gave at MIT years ago, and I was trying in a sort of stumbling way to relate this to other solid-state things that I thought might tie in here. And he said, don't wonder where it comes from. He said, it's a gift from God. Just accept it, use it, don't worry about what's going on.
Lawrence Laboratory physicist Dr. Harry Heckman was there when the wheel first span round. He remembers his reaction.
I'll be damned. Oh, sure, I mean, there it goes. You know, Ridge, you've done it again. And actually, the mechanisms that he did innovation to make the wheel go, and the kinematics of the wheel is it almost looks like it's perpetual motion.
And Professor Elizabeth Rauscher, a nuclear physicist studying the crystals of nitinol, speculates on why nitinol behaves the way it does.
Ridgway's been trying to look at some of the magnetic properties, some of the ferromagnetic properties that might occur in nitinol. These are experiments that really need to be done to give us some clues as to what's going on.
And we'll talk with Stuart Brand, editor of Whole Earth Catalogue, who first drew attention to nitinol in his publication Coevolution Quarterly.
This is a real case of news being so original that the mind, just the social mindset is taking a while to catch up with it. It's not, nitinol was not predictable from anything else going on at the time. It really was a complete flash.
We'll talk with Professor Daniel Cole, who's investigating ways of using nitinol engines to harness temperature differences in the ocean and geothermal springs, to tap waste heat lost in most industrial processes, and most immediately, a solar-heated nitinol irrigation pump.
What's particularly attractive about nitinol, and that a nitinol prime mover in that circumstance, is that the solar collector has the job only of maintaining about a 20 centigrade degree difference in temperature.
We'll talk with Professor Macmillan about a new machine, another invention of Ridgway Banks, which many believe heralds a completely new energy technology.
The new machine depends on stretching of the wire, the absolutely longitudinal stretch. And that is basically a more efficient mechanical motion. It is important that people are working on these things, you know. If it's used as a basis of a heat engine, of course, you need it in a entirely different scale of production from what it's made now. Fortunately, the materials of which it's made, which are nickel and titanium, are both very abundant elements, so there's no question of rarity of materials. And it's not hard to make. Somebody just has to do it.
The thing about this machine which is important to me is that it's possible to scale this design up efficiently. You simply add more nitinol and you get more power out for the, as long as you put enough hot water into it. So this is the first machine that I've personally had anything to do with that could be scaled up to kilowatts or even conceivably megawatts of power.
Research into nitinol heat engines began quietly several years ago with strange devices like this, developed by McDonnell Douglas Aircraft Corporation. Others involved in nitinol heat engine research include the National Aeronautics and Space Administration, the United States Navy, General Motors. Research is also underway in England, Germany, Japan, the Soviet Union, and China. Nitinol can be trained with a double memory to recur to a predetermined shape. In a warm airflow, the branches of this nitinol plate curve out. The force of this transformation has been measured as high as 55 tons a square inch, and in trained nitinol, a cold airflow will cause a reverse reaction. And in some devices, the effect gets stronger with repetition. No one knows why or how far this will develop. But by 1974, some of the researchers working on these devices, a number of which are still classified, were saying in unpublished private and government research papers that nitinol could provide a new means of energy conversion that might have considerable long-term implications. With the sudden advent in the mid-1970s of the worldwide energy crisis, the Department of Energy here in Washington, D.C. began looking for new sources of energy. And in 1978, the Department of Energy, in association with the United States Navy, convened the world's first international conference on nitinol heat engines. It was here at the Navy's Ordnance Laboratories just outside Washington, D.C. that nitinol was originally produced as part of a little publicized program of metallurgical research for the National Aeronautics and Space Administration. The Navy has now produced a special report for the Department of Energy on nitinol heat engines based on their research here at the Ordnance Laboratories Nitinol Technology Center. CNN has learned that the report will recommend the development of nitinol heat engines as a means of helping relieve United States dependence on imported oil.
We see nitinol engines as a real potential for the future. We have done some calculations which show that nitinol is very viable in terms of using waste heat or low temperature heat, which is the largest available source of heat in the United States. Since the energy to run the engines is in effect free, it's waste heat. You don't have to use oil or anything or any other fuel. It's the cost of installation that's important. We ran some calculations here which suggest that if we can produce nitinol at $200 or so a pound, which is within reason, we feel, that you can make heat engines, and these are extrapolated figures, bear in mind, that you can make a heat engine that will recover its own cost if you can run it for 24 hours a day within 2 years, a year and a half perhaps. After that, all the energy you get out of it is for free.
It's free.
And that's the driving force behind a nitinol engine.
At the World Bank in Washington, D.C., they've been watching the research into nitinol. Their program is headed by Dr. Mitwally. I asked him about the Navy's latest figures.
If it's true that it can pay for itself in 2 years, I would say that's very encouraging. But I would like to see that first.
If it looked as though nitinol, in fact, was going to take off, as it were, as an energy source or as an energy converter, would you then choose a particular nation and attempt to see what could be done with nitinol in some large scale?
To start with, if we can have it on its own, or if we can mix it with solar energy, and the end use would be irrigation, pumping, we would be very much interested in the very near future to have something done, and not necessarily in one nation. It could be in many nations in the developing world.
At the United States Department of Energy in Washington, which sponsored the conference, the nitinol research program is headed by Marvin Gunn.
It was, to my estimation, a very successful conference. The proceedings have not been published yet, but they are imminently available. I do know that the proceedings have been put together, and when it comes out, it will represent a very, I think, complete compendium of nitinol state-of-the-art. We went forth with a lot of optimism, you know, that, well, while we'll learn a lot, we won't necessarily decide that we've conquered the world and found something that was going to solve all of our problems, but we thought it was interesting enough and it was feasible enough to look at. It's something brand new and it's intriguing. You know, as you say, there's very little known about it, so we can just think of so many ways of finding out more about it. You know.
Do you foresee finally something like a nitinol economy in certain parts of the world?
I'm not sure what the numbers are in the availability of nickel and titanium, and certainly the manufacturing capability at this point. But I wouldn't want to go that far to think that nitinol would dominate. In fact, I guess what we consider ourselves now is that we're on a petroleum economy, and we're trying to find ways of getting away from that. I see it contributing as a component of, you know, or one of the ways of displacing petroleum as a primary energy source.
From a preliminary copy of the report, CNN has learned that the United States Navy has told the Department of Energy that the development of nitinol heat engines would clearly serve the national interest by helping reduce petroleum energy dependence. The report also includes some startling figures suggesting nitinol heat engines producing power at an estimated $600 a kilowatt are substantially cheaper than both nuclear power and photovoltaic cells. Well, meanwhile, in addition to the release of this report on nitinol heat engines, which will become available imminently from the government printing office in Washington, the Navy has also released another book made up simply of the several hundred scientific papers that have been published on nitinol all over the world. And of course, some of the material is unpublished. There are now reports that in at least one laboratory in the United States, they've produced, but not yet published, details of a kind of super nitinol, a nitinol vastly more powerful than the material we've been looking at. Well, however that may be, it seems clear that the nitinol story has just begun. Kevin Sanders, Cable News Network, Science Report.